or explain what we're going to do for the actual lab. So what is spring constant? So let's do this. All right. Spring constant. So spring constant is a measure of spring stiffness / strength. So it's a numerical value that tells you how strong a spring is. If a spring constant is small, it means the spring is weak. Okay? Slinkies have spring constants of around like 1 point something. And that's because slinkies are not particularly stiff. They're not particularly strong. Okay? If I have a slinky, okay, if I let go of it, it'll go to the ground because it's not a particularly stiff spring. You can see it spreads out very, very quickly and very, very easily. Some springs have very large spring constants. The shock absorbers in your car have spring constants in the hundreds. And that's because they are very stiff. And they do have a large strength to them. So springs that are harder to move are going to be higher spring constants. Springs that are easier to move are going to be lower spring constants. So it's just a measure of how strong the spring is or how stiff the spring is, whichever way is easier to think about. Okay? So what equation is used to find spring constant and how does it work? So the equation we're going to use is Fs, and the S is just to remind you it's a spring, is equal to negative Kx. So Fs is the force of the spring. K is spring constant. And X is distance from equilibrium. Okay. So let me show you this here real quick. So Fs equals negative Kx. So the strength of the spring is the spring constant times the x displacement, which is, again, how far from equilibrium is it. And I'm going to go ahead and set this up real fast so I can show you how this works. Okay, so if I have a spring here, this won't work well enough. The force of the spring is going to be equal to the spring constant, which is a value that's just given for each spring. You may have to find it, but it is set for each spring. And how far from equilibrium it is. So equilibrium is here with no weight on it. When I put the weight on it, the spring stretches out, and the force of the spring is going to equal to how strong the spring is, K, times how far it got stretched, X. So the further it gets stretched, the stronger the force is. The less it gets stretched, the smaller the force is. So it works pretty straightforward how you would expect. So number 3, for this lab, what is the force of the spring equal? So for this lab, the force of the spring equals the force of gravity. Because for this part of the lab, we are always going to hang weight off of the edge. And so that's going to stretch it out, and it's going to balance out again. And when it balances out, these two numbers will equal each other. So for this lab, when you're trying to find Fs, you're going to do it by doing Fg equals mg. Because for this lab, we're actually going to solve for K. And lastly, what's up with the negative sign? So here's what's up with the negative sign. Fs and x are always opposite directions. So for every time you solve this, you have to make one of them negative. It does not matter which one. But you have to make one of them negative. But only one.